Hello. This is Postgres FM. My name is Nikolai, Postgres AI, and as usual, co-host is Michael PG Mustard. Hi, Michael.
Hello, Nikolai.
And we have super interesting guest today, Lev Kokodov. Hi, thank you for coming.
Thanks. Hi, Nikolai. Glad to be here.
Yeah, and the reason we invited you is when I saw PGCat, it was interesting. Like at that time, I had a spike of interest to sharding solutions, and I saw PGCat was started as a connection pooler alternative to PG Bouncer. Actually, at the same time, a few other teams started some new projects, but then sharding was sharding was added. It's quite straightforward way, just comments. It was interesting, but I'm not a cat guy. I'm a dog guy, and once I saw PGDoc started, we focus on sharding. It obviously attracted much more attention from me. So that's why we invited you, actually.
Awesome. Yeah.
Let's talk about, I don't know, like maybe sharding itself, and probably let's start with the idea that not everyone needs it, because on a single Postgres cluster you can grow and reach multi-billion evaluation, go to IPO. I have examples. But obviously sometimes it's really tough, right? Tough job to maintain a huge monolith. So what's your take in general about the idea that you don't need sharding?
Oh, yeah. Well, that's a good one. I agree in principle. So, Postgres can be pushed quite far, and we pushed it very, very far at Instacart, pre-IPO, I should add. But we IPO'd as a massively sharded database, and we absolutely had to, because a lot of things started to run quite slow. We had a lot of writes. Instacart was, you think most apps are 90% read, 10% write. I don't know if that was the case for us. I think we're a little bit more like maybe like 80-20, maybe 70-30, but we were doing a lot of writes.
Hold on, 80-20 means 80 writes, or
no.
reads as usual, reads, right?
Yeah, reads. Right. Yeah. I'm thinking like 90% typical workloads, 90% reads, 10% writes.
Or even more sometimes. Social media is definitely more reads, right? But here's different.
Yeah, it was a little bit different, not by much, but even that small percentage, like 10%, 15% writes, was enough to push our R5 to 24x large, I don't know, like 192 cores, almost a terabyte of RAM over the edge.
Sounds like RDS. Actually, I'm super curious. It's off topic, but I'm super curious about so-called Instacart zero downtime upgrade approach, because we believe at Postgres AI, it leads to corruption. But I hope we will discuss at different time. Like let's hold on to this.
Happy to talk about it on another podcast. That was one of the guys who worked on it. So
consider you invited. I won't, because zero downtime upgrades made on managed Postgres, which doesn't allow to change recovery target was sent.
Yep, I did it myself. We had zero downtime.
Yeah, it's a super interesting topic. Maybe in a few weeks, I really looking forward. So
sounds good.
So I understand that writes, like we can scale reads easily because it's just add replicas until some point, right? But writes, we have only the primary. And you need to go either to services, microservices, or sharding, or combination of them, right? This is several routes, actually 2 major routes here.
Yeah, Instacart actually sharded what we call functionally sharded. I don't know if that's a real term in the industry, but we just took tables out of our main database and put it into a different database. Functional sharding, air quotes.
Vertical split, vertical position.
Exactly, yeah. And that happened even before I joined the company. So that was way before, IPO talks and all of that stuff. So you can run out of capacity on a single machine quite quickly if you use it a lot. Sorry, that's a little bit of a tautology, but that's just the case. Like, it depends on your workload. We did a lot of machine learning, so we wrote a lot of bulk, data a lot, like daily. We would have like hundreds of gigabytes of data that were completely new data every day, basically. So a lot of writes were happening, and sharding was the only way. Basically, we were running out of. Our vacuum was always behind, and when vacuum is behind, everyone gets a little bit scared. Performance is worse as well. we were getting like a lot of lock contention on the wall. That's, that happens a lot. The wall is single threaded to this day, and it's totally fine. But you end up, when you write like hundreds of thousands of transactions per second.
Wall is single threaded is if you use wall writer, but backends can write to wall themselves if you turn it off. Like this setting, I forgot.
Yeah. No, you're right. You're absolutely right.
Yeah.
But there's still a lock. Yeah, they have to grab a log.
Right. We see it in performance insights if it's on RDS, queries are spending time on LW log.
That's the guy. And that's the guy who takes your website offline on Sunday every morning, like a clockwork.
On write attensive workflows. Yeah. And I would say traditional optimization would be let's write less, but I assume only in Postgres 13 wall-related metrics were added to PG statements and explain, right? So it was very difficult to understand which queries. Well, with performance insights, you can, based on wait event analysis, to identify queries which are like wall write intensive, right? And maybe optimize them, but it's still like limited approach, right?
Well, it's limited in its success in a company because when you tell somebody like, "Hey, can you write less to your database?" people are like, "I'm sorry, but is that your job?" Like
you can write less, but we have wall writes are problem for a query. Consider a query which writes to a table and two situations. This table has a couple of indexes versus 20 indexes, and when we insert something, every index gets some insert, and it amplifies amount of wall written for the same insert with each index, right?
It's really important to know that every single index has an important business use case, and that's why it was put there in the first place. So, like all of these are invariants. Like when you say like I have 20 indexes on a table and it's right up like it's by design. And when you want to write more data to that table because your business is growing, like us as a database engineering team, we're like, all right, we're going to make it happen because we can't go to like 25 individual teams and tell them like, hey, can you fix your query? They're going to be like, I don't have the time. I'm trying to sell groceries here. Like I have other concerns.
But anyway, I'm trying to say I agree with you that without sharding, we are limited in like it. We need to squeeze, but it's very limited. And at some point, you cannot say we can grow to X anymore, right?
That's right. Yeah. And that 2x is actually on the low bound. What most engineering leaders expect is like 3, 5, 6x 10 to have that runway. If you don't have that runway in your system, it's a red flag for most.
And it goes to CTO level, basically. The decision is like, should we migrate out of Postgres to I don't know where, right? So
exactly.
I know this so many times. Including sitting on CTO position myself like 15 years ago. Like I know this pain. So sharding, yeah.
It's really funny. You're just kind of sitting there and be like, hey guys, I need 10x capacity. And you're a database engineer. It's like, well, it's the wall. There's nothing I can do. It's the wall. It's like, there's just like a disconnect between these, like, these two people. You just need to make this thing scale. Like that's the end. And a lot of these are out of control. So,
but yeah, we can also enable compression for full page writes. We can also partition so writes become more local and some I don't know, like you're skeptical, right?
I am, because all of that partitioning is great. I would never speak against bad against partitioning, but
not every partitioning. Sorry for interrupting. Not every partitioning. If, for example, people say, okay, we are going to spread all customers evenly distributed among partitions, so this is not going to help us in terms of wall writes. But if you say we will have hot partition, like with receiving most writes, and kind of archive partitions where auto vacuum and everything was going like stabilized. In this case, it's super beneficial for wall writes and write intensive workload optimization, right?
Absolutely, but then you're going to end up having to read those cold partitions anyway. It's a temporary band-aid, which we did. Again, absolutely, we partitioned a lot of tables, and that helped us with a lot of things. But at the end of the day, you just need more compute. It's the bitter lesson of database. I don't know if you're familiar with the bitter lesson in AI, where you just need more machines to solve the problem. It's the same thing in databases. You just need more compute to just be able to read more stuff and write more stuff.
Yeah, I'm still pulling us back intentionally because we are having conversations about like scaling problems, and interesting insight I've got yesterday talking to a very experienced Postgres expert, that partitioning not only helps with data locality, write locality, and full page writes and wall amount as well, but also with backups. Surprisingly, if we do incremental backups with OLG, BGBack REST, with new incremental API, I'm still need to learn about this more, or snapshots, cloud snapshots of ABS volumes, and RDS also relies on it, as I understand. And imagine writes are spread out everywhere, and you constantly change a lot of blocks, versus you change only specific blocks, and some blocks are not changed, and it's less pressure on backups as well. It's interesting, and it affects DR and RPO, RTO. But I just wanted to ask, my understanding, if we go to sharding blindly and miss some optimizations, I remember I was dealing with Mongo, and each node of Mongo, it was maybe 10 plus years ago, I saw each node of Mongo can handle much less workload than Postgres, one node of Postgres. Maybe jumping to sharding too early, it's premature optimization, and you will be not in good shape in terms of how much money you spend on compute nodes, because you missed a lot of optimization steps. What do you think?
No, absolutely. If your first step is my database is broken, I need to shard, you missed a lot. Of course, you should look at all the possible optimizations, and that's really important to keep you on a single machine. I think the benchmark for me is when you need to start thinking about sharding is when you try 3 or 4 or 5 different things, and then you have a person or two working on it full time, and at the end of the day, they're I ran out of ideas.
Do you have some numbers, for modern hardware, how much wall to be written per day,
Sure.
for example, terabyte, 5 terabytes, where it's already an edge, right?
Yeah, for sure. I could give you the exact number. We benchmarked Postgres in the best possible scenario, actually. It was on EC2, it had NVMe drives, it had an XT4, a RAID 0. So we did not want durability, we wanted performance. That thing could write 4 or 5 gigabytes per second using Bonnie++. Now, Postgres was able to write about 300 megabytes per second of just whatever. I think we're using copy, the fastest possible way to dump data into PG. And it's the nature of the beast, right? You have to process it, you have to put it into a table. I'm sure there's a lot of checks and balances going between, and again, lock contention and all of that stuff. So you can't necessarily squeeze out everything out of your machine if you have the capacity. So ultimately, you need to split the processes themselves between multiple machines once you reach that number. And then, for everything else, if you have write amplification, things are getting a little bit more tricky. And then, so I think that's usually the number. Once you're writing 200 megabytes per second of just wall, and you can see that in RDS, there's a graph for that, just wall writes. I would even start early.
Of wall per second. Each wall is 16 megabytes, but on RDS it's 64. They changed it. So how many wall files? No, it's a lot, right?
It's a lot, and that's the kind of scale you're looking at.
10 plus is already too much. Yeah, I agree.
Yeah, and so that's the red line, right? If you're at the red line and you're thinking about sharding, we're gonna have a bad time, and that's okay. It's okay to have a bad time. These lessons are learned when you're having a bad time. I had a really bad time.
Yeah, and I pulled BC calculator just to check 200 megs per second. It gives you 17 terabytes per day. If it's
that's mild, honestly. For what we did at Instacart, we had petabytes of wall in S3 after a week, and that's just, again, it's the nature of the beast.
Cluster or multiple cluster?
Single cluster.
That's insane.
It's just it's
insane.
It's called selling groceries. What could I tell you? We had hundreds of gigabytes of machine learning data that would come in every day because the model was retrained on a nightly basis, and all the embeddings have changed. Right? Again, the use cases are almost they're interesting, but they're kind of off topic, I guess, because they're just you just write a lot of data. That's what you do for a living, right? That's what Postgres is for. That's what databases are for. So the numbers are this is the number, and that's when you should split up.
Yeah, so let's probably just for more sane situations, let's say 10 terabytes per day or something of wall data. It's already too much. if you approach that like not soon, it's already a wall you will be hitting, several walls inside Postgres you will be hitting, like, including
Pun intended.
several walls. Yeah, I was trying to say lightweight log, wall-related lightweight logs, wall right, or like there are several of them. Yeah, but it's this is the scale to be scary about.
It's hard to put a number on it because you can push that further, and who knows what's going to happen to your app. Maybe that's as high as you'll go.
And not everyone has local NVMEs because in cloud environment they are ephemeral. It's kind of exotic and risky.
Yeah.
And
it is. It's definitely risky. I love those because when you click reboot on the machine, it wipes the encryption key and all your data is gone. So you better be careful which button you press. There's like a hot restart, which is safe, and there's the actual restart, which will delete all your data. So, stay on RDS if you can.
No, I don't agree here because you should just use Patroni and multiple replicas, at least 3 nodes, and you'll be fine to lose one node.
You lose one, something ran a bad. Anyway, that's
off
totally off topic. Yeah.
Okay, thank you. For me, it's enough to understand like that there are cases definitely when you do need to split vertically, and splitting vertically usually is limited as well. It's hard sometimes, and at some point we need sharding. Yeah, so it's enough to explain that definitely there are cases where you need to scale Postgres beyond one primary. It can be vertical or horizontal, and horizontal is sharding, right?
That's right.
So, good. Yeah, this is great explanation. Well, sharding is definitely needed, but not for everyone maybe, but for many.
I mean, I hope not for everyone. That would be. If we solve the problem once and for all,
actually,
anyone has access to it. Yeah.
We last week, Michael and I had discussion about snapshots, and I said that Cloud SQL has hard limit, 64 terabytes, because this is a limit for GCP persistent disks, including persistent PD, SSD, and I said RDS obviously can allow you to grow further, but beyond 64, but it's not. After we recorded, I checked, and same limitation, 64 terabytes. It's another reason to have multiple primaries and scale beyond one cluster.
Well, you'll hit that sooner on Postgres because of the 32 terabyte table limit. And actually, I did hit that limit once, and that was a scary error. The only thing that it says is like there's no more bytes to be allocated or something like that in some kind of database file. I'm like, what? And then you're done. Like there's nothing you can do. You have to move data out into that table. You have to take the database offline, obviously.
Even if it's a single table, okay.
Yeah, a single table, yeah, which is actually not uncommon, like 32 terabytes these days.
Well, it's still not super common as well. I see only cases like kind of 10 terabytes for table, and it's already when any DBA should scream, where is partitioning?
Well, DBAs like to scream, but application engineers be like, I can't. Right. Aren't you the DBA? Like, what am I doing
something,
here?
Right? But partitioning unfortunately requires application code changes.
Yeah, precisely.
Yeah, so sharding is needed for big projects, obviously.
Yeah.
Agreed. What's next?
Can we go? I reckon it's time to go back to the origin story of pgdog and obviously then pgcat. It would be great to hear like a little bit of that story, Lev.
Yeah, absolutely. I'm happy to. Do you guys care about the name of the project? I don't know, or do you want to know where the inspiration for that came from?
Sure, it's fun. Yeah.
Okay. Well, when I started pgcat, we just got a new cat, and I really love that cat. And I was working on Postgres, so the two things came together naturally. You could probably guess the origin story of pgdog now. I got a dog. And then I'm like, look, I love this dog. What could I call my next project? Obviously pgdog. Yeah, so the naming issue solved. pgcat came from the idea that it was really simple. Sharding was not even in scope back then. It was just like we ran pgbouncer. Pgbouncer could only talk to one database at a time. It makes sense, you were pooling like just a Postgres instance. We had a bunch of replicas. We needed to load balance, and we needed a load balancing algorithm that was smart. when a replica went offline because of, again, hardware issues, scaling issues, whatever, we needed to remove it from the rotation without affecting, the app.
Mhm.
So we would regularly lose the replica, and then most of the site would go offline because like we had a Ruby gem that would randomize, access to those replicas, and when one of them broke, it's just, it worked okay, but doing this in the application code is really hard. Especially in Ruby, there's a way to inject exceptions into Ruby, like sideline, and basically that breaks your state. So we had like multiple gems working against each other, and we just needed to do that in a place where it made more sense. Like a load balancer is typically outside the application because you have multiple applications talking to it anyway. So I just built a load balancer basically. It was after actually I left Instacart. I was just doing it as a side project just to keep my mind going. So I built it. It was really simple. Used banding logic, which was kind of novel at the time for Postgres. If you receive one single error from the database, it's removed from the rotation. It's very aggressive, but Postgres never throws errors like network related errors unless there's a serious problem. So that actually worked pretty well. I talked to a friend of mine on Instacart. I was like, "Hey, look, I built this on the side. That looks fun, right? Like we thought about this." And he's like, "Yeah, all right." Didn't you quit? I'm like, yeah, but now I have some free time to work on this, right? And he's like, okay. And then he took the code, added a bunch of features that I didn't add because obviously I didn't have a use case anymore for it. And he's like, all right, great, we're going to deploy it, right? And we tried it, and they use it, and they put so much work into it. They wrote a blog post about it. You probably know about this. So that went pretty well, so it's working in production. It's great. And then I'm like, all right, well, sharding is the next one. They have a bunch of sharded databases that we sharded, and adding sharding routing to that would be great because, again, it was done in the application layer, and the application layer routing, I think we all agree is a little bit iffy, especially if you have more than one app written in more than one language. Like you have to repeat the same logic across all apps. So I added just a common system. I knew like there's two sharding schemes at Instacart. One uses the hashing function from partitions in Postgres. I love that because you can actually split data both at the client and in the server. So you have multiple ways to move your data around. And the other one is just a custom one, like we use like SHA-1, take the last few bytes and then mod that. That's just it's random, but it was available in multiple systems as well. The data for that came from Snowflake, so we could actually shard the data in Snowflake and then ingest it into the instances directly, and then on the routing layer in Ruby, same hashing function. The sharding key is always available, so that was good. So I added both of them, and they're like, great, that's great. And they tried, I think, the SHA-1 function, and I think it's working pretty well for them. So that was fun. And then I started another company that had nothing to do with anything. PostgreSML, you might have heard about it. That came from the idea that we shouldn't ingest hundreds of gigabytes of machine learning data into Postgres. Why we should just ingest a 3 megabyte model and run inference online. It was okay. Stayed 2.5 years there. Didn't work out, as a lot of startups do. Left. And then I had some free time, and I'm like, well, what do I like to do in my free time, guys? Writing Postgres poolers. This is what I do. This is what I do to, rest on vacation. I write Postgres poolers. So I'm like, well, let's do sharding for real this time. Let's actually take what we built at Instacart, make it into software, because that's what we do, right? We come up with an idea, with a problem. Well, we find a problem, we find a solution. We write it in code, and we don't have to solve it again every single time manually for hopefully hundreds, hopefully thousands of use cases for this. We'll see. I'm still doing my research. But yeah, so that's pgdog. Sharding is, solution number one. Everything else is, there's obviously, it's obviously a pooler. It's obviously a load balancer. It has all the features that pgcat has. Almost all of them. I'm adding them as I go. It's a rewrite. It's brand new. I like new code. That's what everyone loves to hear. Hey, you rewrote it from scratch. Great. That code that we battle tested in production and serving like 500,000 transactions per second. Well, that's obsolete now, I guess. You're just going to take this brand new code base and check it out. Yeah.
And it's written in Rust.
Yeah, absolutely.
Yeah. It's in my kind of dreams to find some spare time to learn it and try it, because it looks like many folks move to Rust. So what do you think?
Well, it took me about a decade to get good at it. So the sooner you start, the sooner you'll get it. It takes about 10 years to be good at it. So at least that's what it took me. Honestly, I was. That's okay. Again, if you start today, eventually you'll get good at it, and that's okay. It's a journey. You don't have to learn it like immediately. It's such a paradigm shift in how things work. The compiler is very like aggressive about checking for things, especially concurrency errors, which is for multi-threaded asynchronous pooler is very important. I don't have concurrency bugs in pgdog or pgcat because I'm using Rust. Like I don't have data races, and that's really important. And the number of bugs that I ship is considerably lower because the compiler is like, hey, listen, this variable, you're not using it. And I'm like, oh yeah, crap, I'm actually importing the wrong variable here. I'm using the wrong variable. Good catch, because that was going to be a bug. A lot of things that just in other languages are not available, Rust makes really nice. So it's really worth, again, you'll ask anyone who writes Rust to be like, that's the best thing that ever happened to me since sliced bread. I'm like, that's true. I haven't thought about sliced bread in a while, but Rust is great.
Cool.
Yeah.
Another like side question is license. I saw feedback. I joined that feedback. So pgcat was I think on Apache or MIT. I don't remember exactly, but kind of permissive. And for pgdoc you chose AGPL, right? Can you elaborate a little bit why?
Yeah, of course. Yeah, happy to. This is really simple. AGPL is actually pretty misunderstood. You can use that code and the application anywhere you want and never have to share anything back. As long as you use it internally and you don't provide, like you don't use pgdog like publicly as like a service for running pgdog. And even if you do that in that case, all you have to do is just tell us like what did you change and send us patches, right? Go, what do you change? So like it's pretty minimal. Yeah. But it's a red flag for everyone and that's okay. Yeah, I'm building a company around it. Building a company around MIT Codebase is, I think, probably possible. I've never done it successfully. Building a company around AGPL, I think, has been done before, and I think it's probably fine. But if it becomes a hurdle, I'm not like married to it. I just thought AGPL looks cool. I like the ideas behind it. I like free and open source code. I don't think MIT is necessarily the original idea behind free and open source code. I like MIT because I don't have to think about it.
I'm checking PostgreSML. PostgreSML is MIT, right?
Yeah.
Codebase
it is,
also Rust and MIT. So it's interesting how you decided to change it. Okay.
I mean,
I agree with you. It's misunderstood, and but it's already so. It's majority of people misunderstood it, and we cannot change it with single project. So it's reality. Yeah. But you don't care if it's a company. Okay, yeah, like you do it. Yeah.
Yeah, because like if somebody tells me like, look, I would love to use your code, but AGPL is a deal breaker, I'll be like, well, we'll work something out. That's not a big deal, But I think it's a good thing to have a good license. It's important.
You mentioned starting a company around it. It strikes me it's going to be tough. Like, obviously, new code base, the main use cases are at scale. But normally startups, like the easiest way of getting started is serving smaller companies, right? Like it's harder, like going straight to the enterprise with something that's not yet battle tested. Like you've got a plan though. It'd be great to hear like, what's the plan?
What's the plan? It's okay. Don't freak out. It's going to be okay. Yes. It's not actually that uncommon to have enterprise startup products. If the problem is interesting enough, there's always going to be somebody's going to be like, oh, great. Somebody's working on it full time. That would be amazing. At this early stage, how this works usually is I'm looking for design partners. So it's companies like Instacart who are like, hey, this is a great idea. We're going to try it out. We're going to develop it together. And at the end of the day, it's going to be in production because we built it together. And it's actually good because you want to build it with the users. Like you don't want to build it by yourself like for several years and then show up and be like, hey, does anyone need Postgres sharding? And Nikolai's like, well, I don't know, maybe, maybe not, depends. So what I'm actively looking for right now, like Codebase is okay. I'm sure there's bugs in it, performance issues, and that's totally fine. I'm just looking for people who'd be like, this is an interesting idea. Like I like the idea of Postgres sharding. I like the way it's done at the pooler. It's not done as an extension. It's not done as like some kind of like other thing that I can't even think of. Like I like the way it's done. So I'd like to try it out and help you finish the job. By deploying it in production, by benchmarking it, by finding bugs, by reporting bugs, by even fixing bugs would be great, but not required. My job.
I can confirm you are very quick reacting to requests. And I remember looking at PGCat, I had idea that mirroring, right? Let's have mirroring to have like a kind of A/B testing, A/B performance testing right in production, and you implemented it. It was great. I think you were
Actually,
or no?
to be perfectly correct, it was actually Mustafa at Instacart
Okay.
who implemented it
Okay.
because he had a use case for it. He
Right,
was
well-
my design partner.
It's very common request, and the only problem, like, you need to have this pooler already in production to use it. Right? This is the trickiest part because
It's 0 to 1. It's always tricky. New stuff, especially in the hot bath, always going to be hard. But if the problem is there, and if the problem is big enough,
it should be a jump.
I'll find my champion. Yeah, exactly.
Yeah, and you mentioned PGDoc. Maybe let's move back to technical discussions a little bit out of business and license and so on. So first of all, it's not like PGCat. It's not explicit sharding when you command with comments, SQL comments, how to route. This PGDoc has automated routing, right? And second thing, there's no Postgres as like middleware for this, right? So it's just a pooler with routing, right? Can you explain like architectural decisions here and what do you use and like what kind of components like you got a parser from Postgres, right, to understand queries. I'm very curious how you are going to automatically route selects of functions which are writing, for example, right? Or select for update, which you cannot route to a physical standby, a replica, right? Or I don't know, something else, like you are going to, or you obviously will have some limitations, already have some limitations, right? So can you
Absolutely.
talk about this a little bit?
Yeah, of course. Well, select for update is actually really simple. That's a clear intent to write something. So that's an easy one, straight to the primary. No problem. That's an easy one, which I actually should implement. Now that I'm thinking about it, I'm routing it to the replica right now. Bug issue incoming. Thank you very much.
You're welcome.
Thank you. The other one is the functions. Obviously, it's impossible to know if a function is writing or not by just looking at it. Even if you look at the code, you're not going to know. So like static analysis, I don't think is necessarily possible. So for that one I think it should be pretty easy. You put it in the config. You have a list of functions that actually write.
This is what pgpool does, right?
I think so, yeah. I'm not sure, yeah. But,
pgpool does everything, so I'm sure they do it as well.
Exactly. You have to be careful. You can't do everything. People don't believe.
Right.
Yeah. I know that approach is not perfect because if you add a new function, you have to update the config, and you're always going to forget, and you're always going to have issues. So for that one, I don't have a solution. My theory so far is that is not as common as I'd like, but I will probably be proven wrong, and then we'll figure something out, probably. Some kind of migration process that says if you want to add a function that writes, send it through like you should be writing migrations and sending them through the pooler, not some kind of side channel, and you can probably mark that function as like, hey, this function writes. Like just put in a comment or something, and then PGDoc is gonna be like, great, good to know. You're gonna need persistent storage for that kind of stuff, which you could probably implement.
Yeah,
pretty
I
easily.
agree. Some dogs behave like cats sometimes.
Exactly. Yeah, exactly. People will forget to put that comment in, and then there's gonna be issues. But that's just software. When there's people involved, there's always gonna be the more manual stuff you have to do, the more problems there are gonna be. But if you're writing a function by hand in the first place, that's just got to be part of your review process.
Yeah.
I was reading Hacker News comments and somebody asked about aggregates as well. I think there's a limitation around those at the moment. What's the story there?
Well, when I posted the thing, I didn't have support for aggregates at all. But then I'm like, hey, you know what? Let's add some. I've been thinking about it for months. I might as well just do a couple simple ones. So
Nice.
I added like count, simple one. You just sum the counts across all shards. Max, min, again, super simple. I added sum as well. Sum is really just sum everything.
Yeah.
Yeah.
But it's,
Some of the,
let's small comment here. It's MapReduce basically, like an analogy for it. It's cool,
Yeah.
right? So
it is cool, right? This is cool. Like,
you can
it's
scale to billions, trillions, and so on, right?
Precisely, yeah. This is like a MapReduce for Postgres is phenomenal. I'm actually okay. So I'm going to release a blog post in a couple of days. I'm actually sharding and doing MapReduce for PG Vector. I don't know if you've heard about this one.
Nice.
Yeah.
No,
That one's really fun. PG Vector is like a
no,
it's
PG Vector we know, but
We've heard of
what,
it,
what do
yeah.
you do with it? What do you do with it? Like,
Well, you're gonna have to wait till the blog post comes out,
Okay.
but it's really fun. I'm doing both MapReduce and like a machine learning algorithm to route queries in the cluster because like scaling, like searching vectors is a completely different problem than searching B trees. So
sounds good.
I don't know how many people will need that solution.
Well,
but I know it was-
HNSW is terrible if you go beyond 1 million records. It's a big problem still. So
that's the number I had in my blog post as well. I don't know why 1 million just feels like the right number, but that's exactly what I said. Once you're over 1 million, you probably need to shard your PG Vector index.
or use
you know?
different approach. Yeah,
Exactly.
yeah, that's great. And MapReduce, someone told like in the past that PL proxy by Skype, very old tech, also looked like MapReduce, but it required you to use only functions, which is a huge limitation, especially if you have ORM or GraphQL. It's a big showstopper. And also it was Postgres in the middle, right, for routing and for this MapReduce. But in your case, this is more lightweight software in the middle, pgdoc, right? And it does some simple like arithmetic operations.
Yeah.
And do you plan to define some interface for more advanced operations that user could define, like beyond simple sum or count or other aggregates?
I haven't worked much with like custom, data types, UDFs and all that stuff. So that's going to be a learning curve for me. I'm sure it's not that hard, but like once you add custom functions, you need to add custom logic. I think that's should be pretty straightforward to implement if there's a synchronization between, whoever's working in PG.
This would give full-fledged MapReduce capabilities to this, right?
Yeah, absolutely. Yeah,
Opening interesting perspectives, I suppose.
Absolutely. Yeah. If I find someone who thinks this is cool as well, we could definitely build it together.
Not only thinks it's cool, but has some production to try, right? Because just
Absolutely.
Yeah, exactly.
Yes, absolutely. Yeah. I think that would be pretty terrific. It will work pretty well. But yeah. So there's a lot of interesting things about aggregates that, for example, like percentiles, like notoriously difficult, basically impossible to solve, I think, at a sharding level, because you need to look at the whole data set to compute it. You can approximate it. Approximation functions should be like a feature that we add to like pgdoc that says like, you know what, I don't care about the exact number, like average, the simplest one, you could estimate it if
I
you
think
had.
for percentiles, we could define some custom data type, right, to remember how many members were analyzed and so on. Like, I don't know, to bring not just one number from each shard, but a couple of numbers, and then it would be possible to understand percentiles. Maybe it should be.
Maybe.
Not
Yeah.
super difficult.
Feels like a similar,
Yeah.
like Hyperlog had some similar, like,
For
I don't know how you do that cross shard, but it feels like there might be some secret sauce in what they've done already that could be applied more like cross shards.
Yeah, hyperlog is like it's like a counter, basically, like approximates how many members are in a set. Actually, there's an extension for it in Postgres, which
Yeah.
you can use. Yeah, it's pretty fun. But yeah, I need a statistician, like a data scientist, to come and be like, all right, this is how you approximate percentiles, and I'm like, great. Do you know Rust?
Open filters. Right.
Exactly. Yeah.
Well, so what's next? What are you looking? I guess it depends on what people want, but what does tomorrow look like or the next week?
Well, you're gonna be shocked to hear this, but I'm an engineer who does sales now. I literally just as I said, I'm building a company, so I'm literally just sending as many like LinkedIn and emails to whoever I can think of to find design partners, for people to be like, hey, I want to help. This problem exists. First of all, that's the first feedback I need to get. Be like, I would like sharding, I would like it solved, and I would like to solve it your way. That would be great. Or just tell me how you like it to be solved, and if like there's an overlap, and I think there should be overlap, solve it together. So that's what I'm doing mostly. But I'm an engineer, so I need like a safe space from all the social activity. So I still code. So that's why the the PG vector sharding is coming out because I needed to code a little bit, and I thought the idea would be cool. And I'm gonna keep doing that. I'm gonna keep adding like these kind of features, keep adding tests, benchmarks, fixing bugs, finding more use cases like select for update that I forgot. But yeah, that's the plan.
I have a specific question about rebalancing without downtime, right? If one shard is huge, others are smaller, we need to rebalance. What do you think? Like, will this feature first of all be inside open source core offering? Because we remember, like in Citus, it was not until Microsoft decision, as I understand, Microsoft decision to, or like a Citus team decision to make everything open source. And second question, actually, triggering by this question, like, how do you compare pgdoc to Citus?
Yeah, the open source, I would like to stay. I don't foresee myself writing closed source code. Maybe things around like deployments and like orchestrating the stuff. In companies, like my idea, we'll see if it's realistic, is to sell like managed deployments of pgdog to like on-prem deployments to companies. So probably the actual code that orchestrates that stuff will probably be proprietary. Mostly because I'm embarrassed how much bash I use. Nobody really wants to know how that sausage is made.
Do you follow Google bash code style?
Somebody taught me to use curly braces for my bash variables, and ever since then I've been doing that religiously. So I learn new things every day. But I think the core will stay open source forever. I don't even that data migration part, like that's a known. There's a known solution for it. There's no point of building a closed source solution that does the same thing. Like it's already been solved, so might as well just.
It doesn't exist yet, right? So this rebalancing feature.
Well, the rebalancing feature is basically, again, it depends on your sharding key. It depends how you store the data on the shard. Like Instagram wrote that blog post a long time ago where they pre-partition everything into smaller shards, and that's how Citus does it underneath. Like instead of like if you say you want 3 shards, it's not going to build you 3 tables. It's going to build you 128 tables and move them between the shards. And then when one shard logical replication became a thing in 10, so Citus uses that to move things around. I think logical replication makes sense up to a point. You really have to catch the tables at the right time. Once they get a little bit too big, logical replication can't catch up anymore. So that's going to be an orchestration problem. I've seen logical.
You can partition it virtually, like what PeerDB did. Like they implemented virtual partitioning, splitting. If your primary key or partition key in this case allows to define some ranges, you can use multiple streams to copy initially and then even to have CDC. So it's kind of interesting.
That's right.
So
it's funny that you mentioned that because what is it? Postgres 16 allows us to now create logical replication from
binary
replicas.
equals true. Postgres 17.
17?
Or 16. Maybe 16. Maybe you are right. Yeah, I just looked at documentation a few days ago and I already forget. Yeah, but it's still binary. It's good, but it's whole table. Maybe we don't need, if we rebalance, we don't. Well, in case if you split already partitions, it's fine. But if not, I'm very interested to understand design decisions here. It's going to be interesting because I think for sharding at large scale, this is one of the key features to understand this.
So when you started from like a one big database to shard it into like 12, what we did at Instacart was we created a replication slot, we snapshot at 12 databases, we restored them 12 different times, deleted the data that's not part of the shard, synchronized it with logical replication, and launched. So deleting data is faster than writing it from...
Copy it as physical replica first, right? Or copy it logically, like provisioning logical replica, basically dump restore before binary.
No dump restore. So RDS, we were on RDS, so EBS.
This leads us to this discussion about upgrades because recovery target LSN doesn't exist. How let's follow up on this. Like this is good bridge to zero downtime upgrades on RDS.
Mm-hmm. Good. Those are fun. Oh yeah, so the second question, Citus. So the difference is mostly philosophical in the architecture. Citus runs inside the database, which limits it to 2 things. First of all, the database host has to allow you to run Citus, which in a lot of cases is not the case. Maybe because of AGPL, maybe because they just don't want you competing with their internal products. Again, it's business, it's all fair game. And then the second one is performance. When you run something inside Postgres that needs to be massively parallel, you're limited by the number of processes you can spawn and by number of connections you can serve. So pgdog is asynchronous, Tokio, Rust, lightweight. It's not even threaded. I mean, it's multi-threaded, but it's mostly like asynchronous, like task-based runtime. So you can connect. I mean, I'm going to pull up a big number here just for effect, but you could have like 1 million connections going to pgdog from a single machine, and that technically should work because it's using EPOL underneath. But for Postgres, you could probably do like,
You need PG bouncers or something in front of.
You need PG bouncer, and you need most of those connections to be idle, because concurrency-wise, Postgres can only do maybe like 2 per core. That's the myth, at least. Again, like Citus, single machine, they have some kind of support for multiple coordinators, but I think the README just says like, please contact us.
And you, in any case, you're in the hands of Microsoft. You need to go to Azure, or you need to do self-host everything. You cannot use it on RDS because
that's right.
Extensions required. In
That's
your
right.
case, no extensions required. Right, this is the key. So you can run it on RDS because the extensions are not needed. Right.
Exactly.
So you can run it on any Postgres, and I see a lot of guys are like trying to develop extension ecosystem. I'm over time became big like opponent of extensions idea, because we have a lot of managed services, and if you develop extension, it takes a lot of time to bring that extension to managed provider. It takes years. So if you can do something without extensions, it might be better in some cases, and sharding maybe is this such a case, right?
Mm-hmm. No, absolutely, yeah. Because if you develop an extension that gets then installed by RDS, like I don't know if they're gonna pay you
approve
for
it
that.
and support
Approve it or support it or all that stuff. RDS notoriously upgrades like once a year.
We need to wrap up
By
soon,
design.
but like few words about encryption. Does pgdog support encryption now already? Because it's super important and it can be a bottleneck. I know, Odyssey connection pooler was created because PG Bouncer needed 2 layers of PG Bouncers, like to handle a lot of. Yeah, this is
Okay.
what several companies did in the past. 2 layers of
Okay.
PG Bouncers because of handshake. So
Okay.
TLS handshake. And what's in this area, encryption?
Sure. Yeah, it supports TLS. It's using a library, Tokyo. It's like one of the Rust libraries that implements TLS. It's completely fine. You can use TLS. And my personal favorite, I finally found a library that implements the Scram SHA-256 authentication. So now that's finally supported. So
Yeah, I saw MD5 is going to be deprecated in next few years in Postgres. So
it still comes up. Like, I mean, it's been deprecated for like 10 years, and people still use it just because it's really simple to implement. And
Right.
Scram is really hard.
and one more small question about about prepared statements. I know PGCat supported them, right? In transaction pool mode, right? Or
Yeah, the implementation wasn't great, but it does support it. Yeah,
Okay.
pgdog supports them too. Much better implementation this time.
Okay.
Yeah,
cool.
global
Well,
cap.
I'm not out of questions. I'm out of time.
Yes.
But it was absolutely interesting. Like, thank you so much. I'm definitely rooting and going to follow the project. Best luck to you and your new company. And
Thank you so much.
maybe Michael has some questions additionally. Like, I took microphone for too long this time. Apologies.
Well, I'll let Lev. Is there anything we should have asked that we didn't?
Oh, no, you guys are. I think you covered it.
Well, really, really nice to meet you. Thanks so much for joining us. And yeah, catch you next week, Nikolai.
Thank you so much. Bye bye.
Thank you. Bye bye.